Okay, guys, this next problem asks the question, what would be the mass in grams of 4.65 times 10 to the 23rd molecules of water? So I'm going to organize the problem in the same way that I always do. I'm going to do it in 3 steps, with step 1 being, what is the problem giving you, especially in terms of units? So I write down the information given in the problem. And the information given in the problem is 4.65 times 10 to the 23rd water molecules. Now, again, I don't write the word molecule after the symbol for H2O because the symbol should be implied that molecule is the correct vocabulary word to use after that, since there are more than one atom present. And so I'm not going to write down the word molecule, since the word molecule should be understood. Step two would be to say, what is the question ask of me? And so the question is asking that I provide the grams of water. And so when I think about the next step, the basic plan, I'm going to do some conceptual planning. And the conceptual planning consists of 2 parts. At the very minimum, it consists of a basic plan. And the basic plan is to think about, what are the units that I'm asked to convert? So the basics of the problem are asking me to take the units in number 1, the number of water molecules, and convert them to the units in number 2, the grams of water. So step 1 to step 2, as far as unit analysis is concerned. Now, in this case, there isn't a direct path. There isn't a direct conversion factor. There is not a direct singular per expression that it allows me to accomplish this conversion. So I need to do a step-by-step plan that's going to have some intermediate conversion factors between the number of water molecules and the mass of water in grams. The goal is to ultimately come up with a series of conversions that leads from step 1 to step 2. And what you have to do in chemistry is figure out those conversion factors, use your skills to determine the commonalities between those 2 units to sort out what goes in the middle. Now, I know that I can convert the number of water molecules to moles using Avogadro's relationship. And I also know that the number of moles can be equated to the mass of water in terms of the molar mass. And so the unit that goes between those 2 things is moles of water. And so again, the first step will find me using Avogadro's relationship to do the first conversion. And the second will have me using the molar mass to do this next conversion. And so the 2 equalities that I'll use to establish those per expressions, to establish those conversion factors, will be Avogadro's relationship, 6.022 times 10 to the 23rd water molecules is equal to 1 mole of water. And the molar mass, 18.02 grams of water, is equal to 1 mole of water. Now that I have it all planned out, I can start to solve the problem. 4.65 times 10 to the 23rd water molecules. And if I look at the step-by-step plan, it says you're going to need 2 conversion factors according to our plan. And so let's create the correct per expressions. Let's create the correct conversion factors. And so I noticed that the units in the numerator at the beginning of the problem are number of water molecules. So I want the number of water molecules there. And if I go back to my plan, I'm converting to moles of water. So I want to make sure moles of water goes in the numerator of this first conversion factor. And so I can use Avogadro's relationship to establish that. And that means that 6.022 times 10 to the 23rd, that goes on the bottom and 1 goes on the top. And so from that same plan, I know that the next step needs to cancel moles from the first conversion factor and into the second conversion factor. That means that moles of water in the second conversion factor is in the denominator. I also know from the plan that I am going to get an answer that's in grams of water. So the second conversion factor will have grams of water in the numerator. And so I can use the equality for molar mass and put 18.02 grams on top and 1 mole on the bottom. The rest is all just calculator work. So when I do the calculation and I round it to the correct number of significant figures, I get 13.9 grams of water as my final answer. Also, take a look just to show you that the units do cancel. Moles of water, or excuse me, the number of water molecules cancels with the number of water molecules in the first conversion factor. Moles of water in the first conversion factor cancel with moles of water in the second conversion factor, leaving us with the units of grams of water. Okay, guys, thanks.